which I loved. So we'll come back to this in a sec. Mike asked me a question about, prime numbers and the occurrence and whatnot. Here's a graph.
Go back to the
We will. I promise. I promise. This is pretty cool. This is what theoretically should happen if 24 of you flip a coin at the same time, and this column is the number of heads or tails. It doesn't matter to me. We'll say it's heads. So these are people that are going to keep flipping, if you will, keep flipping. So after one flip, if 24 of you flip, this is the probability distribution. This is what we spend a lot of time in 243 talking about. What is going to happen on average? Now, Mike, you've already kind of nailed kind of what's going to happen. Half should move on. Now, half of 24, hang on one second. Excel has the axis skewed a little bit. Let me just select the data real quick. Edit. I want to make it this. So if you look at that graph, the highest point of the graph is directly above 12. That should make sense. Half of you should get heads and half of you should get tails on average. On average. Not in every trial. We never saw that, did we? We only saw one trial where exactly 12 of you got heads and 12 of you got tails. That was it. Two. Sorry. But the point is, it didn't happen very often, did it? It didn't very often. We got 16, we got 9, we got 9, we got 11. But if you look at those numbers, 16, 9, 11, and 11, here's 9. 9's bar is pretty high too, yeah? 9's bar is pretty high too. 16, it's a little bit lower, but if you will, you're still kind of in the chunk of the curve. Has anybody ever seen this curve before? If you've taken psychology and sociology classes, you've heard it, or you've seen it in other classes. Kyle, what do we call that sometimes, yeah?
No, I'm sorry.
Oh, you weren't! I'm sorry, I saw a point in this. Just stretching your fingers. Benji is a bell curve. It's a bell curve. And it's actually technically a binomial distribution, but at the higher the number of trials you go, the more and more bell curve it looks. Now, what this means is, how likely is it if every one of you, all 24 of you, flipped your coins and you all got tails? How unlikely would that be? Well, it would be highly unlikely. There's the chance of it happening, 0.0000006. So take two of those zeros off, 0.00006%. That doesn't happen. I mean, it happens. It just happens that rarely. But this is why I had to have you all seed your randomizer, yeah? Because if you didn't seed your randomizer, everybody pressed enter, every single one of you would have gotten heads, and or every single one of you would have gotten tails. You all would have matched. Very boring data that way, right? Very boring data. Much more fun if we all have random data. So the 17, I bring this up, Mike, because the chance of getting 17 heads, like I said, like 24 to 17, your prime number, 2%. There's the bar right there, right at 2%. You're getting pretty unlikely. There 2 in 100 trials, you should expect to see that. So if we kept going, and I don't know, the probability of it, if we kept going with this chart, I would predict that if we did it 100 times, we would expect to see that 17 in that next trial, probably once. On average, it should happen twice, but that doesn't mean it's going to happen twice in 100. It means it's going to average twice in 100. So we'll see it eventually. It's just that we didn't do it enough to see it today. Okay. Because it's too far away from the middle of that curve. Fair enough? Yeah. Great question, great point, great observation. Fantastic. But here's our data. So here's what I want to model right here. Boom. What I did was, I took our data and I averaged it across the way. Now remember what you guys said. You said on average you should see 12 people flipping heads and tails and/or tails on the second trial. We got 11. That's not bad, is it? That's not bad, especially since how noisy our data was. We had 9s, we had a 16 or 2, right? But it averaged out to 11. Now, theoretically speaking then, if we had gotten 12 on that second trial, we should have gotten 6 on the next trial. We got 5.4. That ain't bad, is it? Now 2.7 is exactly half of 5.4, but it's almost 3 as well, which would have been half of 6. 1.5 is half of 3, which is what that would have been theoretically. 0.4 is getting close to a half of 1 and a half to 0.75, and so forth and so on. This is actually almost a half of 0.75. So theoretically, our randomizers look pretty good. Let's take a look at them. Take this data, L1, L2, TIs. Go ahead. I'm going to shut this down for a sec.